Hello and welcome to the Cyber1 YouTube channel. My name is Ray and this is part 3 of Fred's Brain. In part 1 we looked at the general layout and the reason why we break up the program into lots of different files. Part 2 we looked at the servo and the servo service within MyRobotLab. Since then, I've made a couple of changes to the start.py file, so I just thought I'd quickly go over the changes there. So the only real change is in the order in which I'm executing some of the sub-files. Still starting up the GUI as normal, but what I've done is I've now moved common variables to just after the graphical user interfaces, and I've put them before controller pies, which are the controllers as we went through in the first video. I've moved IO pi to just after the controls before the servos. That's the major difference that I've made now. So we're starting our IO routines before the servos. In this video we're actually going to look at the IO services, or at least some of them. So let's start with the IO program. And I've been working on this one. So one of the first things we do when we launch this routine is call on its configuration. So let's have a look and see what we do in the configuration. In our configuration, we print to the standard output that we're creating the IO config. Next thing we do is we start the PIR service, or we tell it what we're going to do with the PIR service. In this case I'm enabling it, and I'm going to attach it to the Arduino Nano on pin 2. Now this is digital pin 2. If you're running this on the Nervo boards, you would connect it to the left Arduino and it would be on pin 23. Now passive infrared is actually quite a simple system. It uses a series of small lenses to create areas that are not really seen by the single sensor that's in it, and areas that are near enough amplified for that area. It uses single infrared level sensor. So as a warm body which is emitting infrared light moves from an area that's fairly blind onto an area that it can see a lot of light from, the total infrared light level that it's seeing changes, and it's looking for this change in level. So as you move across its field of view, so to speak, you come in and out of view of the actual sensor, and that triggers the sensor to say there's a person in front of it, or a change in the heat level that it's seeing. So we'll see more about that one when we get to that back in IO. In this service section we also have two ultrasonic sensors. So those of you who have seen Fred will know that there are two ultrasonic sensors mounted on his chest. The files to support those are available on the Inmoov site. There'll be a link in the description, so you can download those if you want and install a pair of ultrasonic sensors. Now what we're doing is, because there's two sets, we're going to enable each of them. We tell it what we've attached it to. In this case it's the Arduino Nano that's in his chest, and what pins they're attached to. So pins 10, 9, 12 and 11. When we ping, we send out a ping and then we wait a time for the echo to come back, and then we send another ping. Now the time it takes is not very long, but just to reduce the load on the system, and remember it is only a Raspberry Pi I'm running in Fred, we've reduced the ping time. Increase the ping time to 1 second. I might bring that down to half a second in the future, so it pings a little bit quicker. We'll see how we go. I have got a bit of a description in the file as to how ultrasonic works and the speed of sound in air, so you can have a read through that when you're looking at this program. Battery voltage monitor is the Arduino Nanos and the like, Arduino Megas and so forth, have multiple analog input pins. Now on the Arduino Nano, it actually has 8 analog input pins. If you use I2C interconnection bus, it uses 2 of those pins, A4 and A5, so you can't use those for analog if you're using I2C. Because I have multiple power sources, 2 batteries and a possible external power source, I wanted to be able to monitor them independently, but I also want to see what the currently selected power source is. Remember that at the moment there is no feedback to the system to say which power source is selected, but it can do a comparison between the currently selected power source and each of the different power sources, and 2 that match are most likely going to be what's selected. Now I've connected the currently selected power source to A0, and I have got a video on that where I've put all this resistor divider network in for this. A1, A2 and A3 I haven't yet connected to anything, but will be connected to the 2 batteries and the external power source when I get to it. I did create a pole interval for it, but I'm not using that in the actual program because it doesn't actually work that way. But more on that when we get to it. We've got a NeoPixel in the system as well, so we've enabled the NeoPixel here. We've got the stomach attachment of the NeoPixels. In this case, I've attached it to the Arduino Nano. Now, just a bit of a note. If you're running the Manticore version, you cannot run the NeoPixels and the ultrasonic sensors on the same Arduino. If you're running Nixie onwards, it will work fine, but keep that in mind. There were several changes made to the way servos and the ultrasonics work when they moved from Manticore into Nixie. So yeah, definitely if you're running with Manticore, you can't put the NeoPixels on the same Arduino as you do pretty much everything else. Anything that uses an interrupt will cause all sorts of problems with the NeoPixels. Right, now I've also added in inertial measurement unit. I've got provision for 2. In this case, I've got one connected to the Raspberry Pi on the I2C bus on it. The other one I've put in the stomach and connected that to the Arduino Nano. And those who have watched my previous videos will have seen that happen. So let's go back to I/O and start working our way through the program. So one of the other changes I've started making to the program, and you'll see this more and more throughout the program, is a little bit of a sanity check. So what I've done is I've looked at PIR attachment, and I've checked to see if it's equal to, say, the Arduino Nano, and the Arduino Nano is not enabled. So that's what this not's all about. So what we're looking at is, if both these are true, this statement becomes true. Or if this statement, and it's actually, I learned a new trick with this. So let me just tab. As long as we keep it tabbed out, we're right. So what we're looking at, or if PIR attachment is equal to Arduino left and the Arduino left is enabled, or Arduino right and Arduino right is enabled. If any of those are true, then it's reversed by this not, and so it doesn't execute the command afterwards. If none of these match, in other words, if let's say we've got the PIR set for Arduino Nano, and Arduino Nano is not enabled, then that will be false. So will these, because they won't match. And with the not there, because none of them have matched, it becomes a true and executes this command, and this command is to disable the PIR. This only works if you're trying to use a Arduino that is not enabled. And that makes it easy. If you need to disable an Arduino for some reason, like testing on a different version, then you can just simply disable that one Arduino and everything that's attached to it will stop working without crashing. Okay, so if our PIR is enabled, then we start our runtime service. So runtime start in the PIR service. We attach the PIR to the Arduino on the pin described. In this case it was 2. And we turn verbose off because it gets to be annoying in the logs when you're trying to find other bugs. And then we enable the PIR. In other parts of the program, we can now capture whether the pin has detected, or the PIR has detected its presence or not, and use that. So that will be further on in the program. Just save that so I don't forget it. Alright, so the next thing we want to look at is the ultrasonic service. And the ultrasonic service, it's very much the same as the PIR, in as much as we check to make sure what it's attached to actually exists. And if it exists, we're happy. We don't disable it. If the only place where this enable left ultrasonic is set is in the configuration file, and it gets overridden by this if the Arduino that it's attached to is not present or not enabled. As long as it's still enabled when we get to this line, it'll set up our our ultrasonic. So as per normal with a MyRobotLab service, runtime.start, what we're going to call our service, and the name of the service that we're trying to start. Once we've started that, we attach it. So in this case, we're attaching it to the Arduino Nano, which we did in the configuration. And we attach the Arduino Nano left ultrasonic pin 1 and left ultrasonic pin 2. So that tells MyRobotLab which pins it's connected to on the Arduino, so it knows which one to send the pulse out on and how long to wait before, or time after it's done that, which pin it's going to be looking for the response on. It actually does that on the Arduino rather than back in the main computer, and so that service within the Arduino reports back the timing. I could have had it subscribe to a routine, a callback function, and that print in the log, but again, a little bit of noise in the log when you're trying to hunt down other bugs, so I've disabled that with a hash to turn that whole line into a comment. And I do use that line elsewhere in the program to use in the live functions, where we actually use the results of the ultrasonic. And we do exactly the same thing again with the right ultrasonic. So we check to make sure the Arduinos are present or running, and then if they're not, we disable it. If it is, we then create the service, right ultrasonic, runtime.start. The right ultrasonic is passed as the name. It should match this one, and the name of the service that we're starting. So we have now got the same service but running twice under different names, left ultrasonic and right ultrasonic. I've left this defined as a defined method for the callback, but I'm not calling it back. Now this is the fun service I had trying to create the battery monitor, and it took me a while to get this one worked out. So I've created an array of 4 battery levels, and I initialize that to 0. I do our standard check to see if the appropriate Arduino is attached. I didn't. We did do the other one though, didn't I? Yeah, I did. Okay, so we do our standard checks to make sure that the Arduino that we're using it on, and in this case I've only configured it to use the Arduinos. It is possible to use another service, but I haven't installed any of those on the system, so it's something I might have to look at down the track. There's a 4-channel I2C input module, and you can start it, but you read it differently. So let's just look at the Arduino for the moment. So we work out, I actually reinitialize each of the batteries to 1 as I work out how many batteries we're using. Now that's something that I should point out in the config. For the enable battery monitor, we specify the number of batteries that we're monitoring. If we set 0, it disables the battery monitoring. 1, it will only watch the first pin. So it works up through each pin. So 1, 2, 3, 4, etc. For the number. I've only allowed, or I've only have provision for 4 inputs, and they can be any of the inputs, and you specify it here as to what they are. Next we define the battery monitor published pins callback method. Now it will pass back an array called pins, and we can actually, if pins is not null, not none, in other words there is actually something on it, we can run through a loop for the number of pins that are returned. Now the reason for this is each time the callback is called, it isn't necessarily going to return all of the pins that we're looking at or looking for. It may also return pins that we're not interested in but were called by other sections of the program. For example, D2 for the PIR will quite often turn up in this list. So we look at each pin in turn that's returned. We look for the name of the pin, in this case it's .pin. If it's equal to the battery monitor pin 1, in this case A0, then it will copy the value of that into battery level 0. And we repeat this for this test for each battery each battery monitor pin name, one after the other until we have a success. So it turned out this was the easiest way to read it, and it will ignore any of the pins that we're not interested in, and it doesn't matter if they're not all reported in this callback. It might be recorded in the next callback as an individual pin. It took me a little while to figure out how this worked, and this is how we read it. Again, we're looking to see what we're attaching our pins to. Now, the assumption is that all of our battery monitors are connected to the same Arduino. it is sort of a requirement for it. So in this case, all of our pins that we're using are going to be connected to it, and we can, or what we do is we look for, is it the Arduino left? If it is, we set the board as a mega, assuming, I'm making the assumption here that the Arduino is on the left is going to be a mega, the Arduino on the right is going to be a mega, and that the Arduino Nano is going to be a nano. It may be something we change down the track if people are using different types of Arduinos and are looking for multiple Arduinos in there. And there are use cases where that might occur, but more on that later. Once we've specified or attached our listener to the appropriate Arduino, whether it be Arduino left add listener, and we've set the AREF and we've set the board type, I've got an error in my program here. I need to copy that and change for the different types for each of these. So we'll fix that right now while I see it. And you'll see how easy it is to fix these bugs when I find them. So we'll do the Arduino left first. Copy that, paste it to replace that one. And that all works. So someone told me once that the most common keys used by programmers are Control-C and Control-V. I didn't believe them until I started working on this program. So I've now fixed that little bug. Right, so all this does is add the listener so that it will call back this program here every time there is an event occur with the pins, where it reads the pin values. Okay, so the next big one that I worked on was the NeoPixel ring. And the good news is it works very well on the Arduinos with the Ultrasonics when running under Nixie. Not so much under Manticore, you do have to put it onto its own separate Arduino. Okay, so we're going to go through and we're going to do the same as we've done before. We checked a bit of a sanity check, make sure that the Arduino we are connecting it to is in fact present. And if not, we'll turn it off, we'll disable it. And that's handy because we've got other functions in the life areas where we're actually going to check and see if it's enabled. And if it's not enabled, we don't try and call it. If it is enabled, we call it. Because we will override the enable stomach NeoPixel if the Arduino doesn't exist or isn't enabled, we can effectively shut it down completely in the program and not create bugs. Alright, so let's make sure it's enabled, and then we go through the stock standard process of every service in MyRobotLab. We will call runtime start to return us the object. We're going to call it stomach NeoPixel, and it is the NeoPixel service. Once we have done that, we will attach it to the appropriate Arduino. In our case, we're attaching it to the Arduino Nano. We tell it which pixel that we're going to be attaching, which pin we're going to be attaching it to, which is specified in the configuration, and also the number of NeoPixels that we're using. Now, I should probably go back to the configuration and show what I'm doing there as well. Actually, I'm not doing a great deal with the NeoPixels here. Now, I have created in the live functions a NeoPixel mode for different ways of running it, and that comes into play later on. So we'll look at that at probably in a future video. Okay, the MPU 6050 is an inertial measurement unit. That is, it measures the acceleration either linear or in rotation around 3 different axes. Using the inertial measurement unit, we can tell which way is down, or if the robot is moving, or if it's falling. We can also see if it's rotating. So there's a number of things that we can get in the way of information back. Now, one of the things that we have discovered, this is at the time of recording a bug in Nixie, the MPU 6050 is an I2C device. It connects to the I2C bus. Now, I have 2 I2C buses in Fred. I've got one on the Raspberry Pi, which I've attached MPU 6050A to, and then we've got one on the Arduino Nano. And for those who are interested, yes, the Arduino Mega 2560s each have one as well. Now, MPU 6050B is attached to the Arduino Nano in this case. And because of a bug that is currently present in the Raspberry Pi in service for Nixie, it doesn't currently work on the Raspberry Pi. It's not creating an error, like a fault and crashing out as such. What it is doing, however, is generating incorrect data. Data that doesn't really gel with sanity. So as a result of that, we can't really use it on the Raspberry Pi at this time, which is a bit of a problem. And I'm not concentrating on what I'm doing and making errors. So one of the things that we tried, and this was based on advice from Kay Waters, was to initialize the DMP initialize. As it turns out, we don't actually need to initialize the DMP with the 6050. That's for use if you're using functions that are part of the MPU side of the 6050. But we've initialized it anyway. It just takes a little bit longer to start it up. So that's the system in a nutshell for the I/O. How we actually use them, we're going to come back to at a later date when we get down to live functions. We've still got speech to go through before we get there, and then life is actually broken down into lots of subroot functions as well, so we'll look at those in another video. If you do like these videos, don't forget to click on like, don't forget to subscribe, ring that notification bell. If you have questions, we have a Discord channel, there'll be a link in the description for that. I also have a Patreon account, so I'd like to thank my 2 Patreons, Go Lucky and El Morales 45. They've been great support and help promote the channel and keep it going. If you'd like to join them, you're welcome. At the moment, they are getting videos 2 weeks ahead of everyone else. And we will see you in the next video.